Hi everyone, Zach here, and welcome to lesson 19 of this series, Learning C++ by Making Games. In this video, we will go further into how to use loops in our programs. This video has been brought to you by my Patreon sponsors like Nemian Games. In this video, we'll talk about the types of loops again, and we'll go over loop control statements, and then I will provide 8 challenges for you to attempt, and then I will go over the solutions, or possible solutions, to those challenges. That said, if you are struggling with loops were one of the harder things for me to get. Actually, they were harder for me than pointers were, and most people tend to find pointers harder. So that said, if you're struggling with this, some advice. 1, rewatch this video. Go back to videos 8, 9, and 11, paying particular attention to video 9. And if the descriptions and the work we did in video 10 don't really help you understand it, I would say draw it out or write it out in ways you understand. So when we iterate, when we do the process multiple times, actually write or draw that process out. And for me, it was actually drawing the process out that made how loops operate click in my head. Alright, that said, let's get started with our types of loops. So let's start by exploring the various types of loops. And the first one we've already kind of seen, and that is the while loop. And the while loop repeats a statement or group of statements while the condition is true. And the key thing to know about a while loop is it tests the condition before running the loop, which means that if the condition is not true, the loop may never run, or if the loop's already running, it will break out of the loop and go on to the rest of the code. We saw this in the number guesser game. If you guess right initially, our while loop doesn't run. If you guess wrong initially, the while loop starts, and when you guess right, the while loop is broken because the condition is no longer true. There is another form of while loop known as the do-while loop. The do-while loop repeats a statement or group of statements while the condition is true. However, it tests the condition after running the loop, which means the loop will run at least once. So the while loop tests the condition before running the loop, and the do-while loop tests it after. Next, we have the for loop. And the for loop, there are multiple types of it, and we'll explore the basic type, comma operators, and bounds-based for loops. But it executes a statement, a group of statements, for a known length of time. And I'm going to put known in quotes later on, and I'll explain why. We also have nested loops. And nested loops aren't anything in particular. They're a combination of the loop types. We can nest conditional statements, as we talked about in earlier videos. We can also nest loops within each other, and there can be a mix and match of the types of loops nested within each other. So if you understand our sequence, so running the code from top to bottom, if you understand our selectors in terms of the conditional statements and looping, you can already pretty much do anything in programming. This is the basic foundations that you need in order to learn any programming language. So that said, let's explore these in more detail. So let's start with a refresher. Let's look at the while loop. And if you need more information on the while loop, please go back to the earlier videos or check out the links in the description below. The syntax for the while loop is fairly simple. While, our keyword, and then in brackets our conditional statement is true, the code will be executed. So in our example, we have an integer, x, set to a value of 100 or initialized to a value of 100. So while x is greater than 100, we are going to run the code in this block. And we print x, and then we decrease x by 1, and this will then go back and check, is 99 still greater than 100? It is. It prints 99, it decreases it to 98, it goes back and goes, is 98 still greater than 0? It is. So it prints 98, and so on. And when we get down to a value of 1, it prints 1, it decreases this to 0, it checks, is 0 greater than 0? It is not. So we break out of the loop, and we go down to the line after the loop, and we print the word words liftoff. So this is how you can do a countdown using a while loop. So next, we have the do while loop. And because we haven't used the do while loop before, we're going to explore this one in a little bit more detail. So a do while loop runs the statement it wants to execute first, then it checks the condition, as I said previously. The syntax of the do while loop is fairly simple. It involves two keywords. First, do, the first keyword, then the code you want to be executed, or the statements you want to be executed, while our second keyword, the condition. So if we look at this in practice, we can have an integer set at 1, and then we can output the value of x is 1, and then we increment it so it's 2. The condition is that while x is less than or equal to 10, keep running this loop. So 2 is still less than 10. So we then do the loop again, and we print out the value of x is 2. And we do this until we reach 10. When the value of x is 10, it increments it to 11, and then the while loop checks, is 11 less than or equal to 10? 11 is not less than or equal to 10, so it breaks from the loop and it continues with the code. So this is an example of how we can count up using a do while loop. Next, we have for loops, and there are multiple types of for loops, but we'll start with the most basic. A for loop runs code for a known number of times, and it can be known by the programmer, but it has to be known by the system. What I mean by this is we can write a set of code where we're saying exactly how many times we want the loop to run, and thus it's known by us and the system, or if we pass a vector into a for loop, we as the programmers might not know the size of the vector at runtime, but the system will. Now, the syntax for a for loop can get a bit confusing, but it's relatively simple. So the syntax for a for loop has the word for, our keyword, then a statement, our first statement, followed by a semicolon, our second statement, followed by a semicolon, and our third statement, and then curly brackets with the statements that we want to have executed if the condition is true. The first statement is our initialization statement, and this statement is executed once and only once each time the for loop is called. Then we have our conditional statement, which is run every time the loop iterates. And then we have our third statement, which is executed after the for loop's body, so the code inside the curly brackets, is executed. So for example, this might look like our earlier do while loop where we're counting up. We have for, our keyword, and then we declare and initialize an integer I at 0. We check, is 0 less than 10? It is, so we run our for loop and we print the value of I is 0. It then increments I. I is now 1. I is still less than 10, so it prints the value of I is 1. It then increments it to 2, and it checks, is 2 less than 10? It is, so it prints the value of I is 2. It does this until it gets to 9. It says the value of I is 9, it increments 9 to 10, and 10 is not less than 10. And so it breaks from this loop, and the code goes on to what's ever after our for loop. Next, we have for loops using comma operators. Now, these are rarely used and can be very problematic if you get them wrong. And when they are used, they're mostly used to initialize loop variables. And a comma operator in a loop allows for the expressions to be separated, but both expressions will be executed. So an example of this might be something like if we have a integer I and j, and we've initialized I as 1 and j as 2, we check then, is I less than or equal to 5? If it is, we execute the code where we print I times j is equal to the product of the two. So we'll print out 1 times 2 is equal to 2. And then we'll increment, in our example, I and j. So I becomes 2, j becomes 3. It then prints 2 times 3 is equal to 6. It checks, is 2 less than or equal to 5? It is, so it keeps going. And then we have 3 times 4. It checks, is 3 or less than or equal to 5? It is, so it goes on to 4. It goes 4 times 5 is equal to 20. It increments it to 5, and 5, it checks, goes, well, 5 is equal to 5, so we still do it, and then increments it to 6. At this point, 6 is greater than 5, so it is not less than or equal to 5, and we break from this loop. We won't really ever use this, but it is just something you should be aware of, and there's more information in the description about the comma operator and for loops. Next, Next, we have a special loop known as a for each loop. This is also called a range-based for loop. It is originally from Java, however, it was ported over to C++ in C++11. It is still around in newer versions of C++. The key differences are there are no initialization statements, so we don't have statement 1. There's no written conditional check, statement 2, and there's no change of the index after the loop is executed, so there's no statement 3. It uses array and other, such as vector, list type structures. Now, at the time of recording, there are some things that you may not be aware of, even if you are aware of C++11, that you can now actually transverse and reverse loops, for example, using particular functions built into certain headers. However, those headers, like ranges, are not fully supported by Visual Studio 2019, and therefore we will not be using them in this series. So, let's take a closer look at our range-based for loop, or our for each loop. As previously mentioned, the syntax is slightly different. We still have our for keyword, except for now we have our element declaration. So this is the type of variable being stored in our vector or array. We then give a loop variable a name. So this is a variable that will only exist within the loop, and we just give it a name. And then we have a colon followed by the array name or the vector name. And this tells the system how many times a loop needs to be run. So that's that known element, and it runs based on the length or size of the array, and then it executes a statement in the brackets. Now, there are two ways to do our element declarations. The first way is to flat out state what that particular element is. So is it an integer? Is it a double? Is it a string? Is it a character? In our example, we have an integer based array called ARR that stores 4 values, 10, 20, 30, 40. So we say for our variable type is integer in this case, because that's what our array is, for int, and then we say a variable name x, run the loop the length of this array, and it will print out the value is, and then it'll print what that value at that part of the array is, and then go down to the next line. So if we ran this, it would print the value as 10, then it would print the value as 20, then it would print the value as 30, then it would print the value as 40, and the loop would break. Next, the other method of our element declaration involves another keyword, and that keyword is auto. So auto can be used to make the compiler determine what the array type is. So all we have to do is change out int for auto, and it will know that x in this case is an integer. Now we can have further control over loops by using control statements, and the three main control statements that exist are break, continue, and go to. Break terminates the loop and goes to the code directly after the loop. We can also use this in switches, and we'll explore this later when we get into switches to stop what's known as fall through. Again, we'll explore that when we get to switches, which we will use in our hangman game. Next, we have continue. Continue skips the rest of the code in the loop, and we'll use this in one of the challenges as an example, and immediately resets its conditions before reiterating the loop. And finally, we have go to. And all I have to say on go to is do not use it. Simply do not use it. There are better things we can use. It is out of date, it's clunky, and it causes problems. Do not use it. Do not worry about it. Pretend like it doesn't exist. Having done all of this now, I think you are ready to go and try some of these out and test your knowledge on loops. So I'm going to present you 8 challenges. A copy of them are in the description below, and I want you to try these on your own first and then check in with the rest of this video to see how I've done them. Now, there are going to be multiple ways to do these. So if your code works and you're using loops, then good. It doesn't need to match my code. I just want to make sure that you're able to use them. Now, in some cases, I say it doesn't matter that it doesn't match my code. Just be aware that you want to use fewer lines of code to write your loops. Now, I do put an extra line in by moving my bracket down 1 line, but that isn't what I mean by extra lines. All right. So that said, our challenges are, first, I want you to create a loop that prints the word yes 5 times. Then, I want you to create a loop that counts from 0 to 10 in steps of 2 without it displaying the value 0. I then want you to create a loop that displays all values evenly divisible, so no remainders, by 20 between 0 and 10. So it should display 0, 20, 40, 60, 80, 100. Now, you'll notice that there are some tricks. And then I want you to create a loop that displays all values of 1 to 10 in rows of 10. So the first row would be 1 to 10, the second row would be 11 to 20. Now, do be mindful of there are some little tricks in this, like with the second challenge that, it's not really from 0 to 10, it's from 2 to 10, since we are skipping 0 and we automatically are going to skip 1. So just think about how you want to set it up, and I can show you some different ways to approach that. So our second set of challenges are: create a loop that determines if a value is a prime number or not. Create a loop that takes a positive integer and factors that integer. The number of iterations should be equal to the value entered. So if you enter the value 6, it should iterate the loop 6 times, from 1 to 6. And that final iteration should have a value of 720 printed on the screen. Create a loop that fills an array that stores and then prints, using the loop, how long someone has exercised each day for a year. Use random numbers to fill this array. And then create a loop that takes a set of characters and prints them in reverse order. So if you have an array that's ABC, it should print CBA. Alright, so that said, go ahead, start a new project in Visual Studio, try to complete these challenges, and then check in to see what I've done in my project. Alright, as you can see, I have a relatively empty new project. All I have in here are comments on the challenges, so I have challenge 1 and what I'm looking to do. So I want to create a loop that prints yes 5 times. So what I'm going to do for this one is fairly simple. I'm just going to give myself a bit of space to start. And I'm going to do for our keyword int of I is equal to 0. Actually, I'm going to initialize it this way. I'm going to use a constructor. If I is less than 5, then I want the loop to run. And I'm going to, every time this loop runs, iterate it through. And all I'm going to have in here is an std cout, so console out, the word yes. And then, just so it's easy to read, I'm going to do an end line. So that's all this loop needs. So if we hit run, you can see that it prints yes 5 times. Alright, so that's that first challenge. All I'm going to do is I'm going to highlight the code, and I am going to hit Control-K-C to comment it out, and I'm going to collapse this down. I'm going to get rid of that space there. Our second challenge is we want to create a loop that counts from 0 to 10 in steps of 2 without displaying 0. Now, there are a couple of ways of doing this, and I've mentioned there are a few tricks. Actually, I have versions 1 and 2. It's actually going to be 3 versions. So let's start with version 1. What we're going to do here is do a for int I, initialize this at 0, semicolon, is less than or equal to 10, because we want 10 to display. And then we are going to then do I plus equals. So if you don't remember plus equals, go to our math operator video 2. So we're going up by 2 each time we iterate this loop. We are going to then execute this. So we don't want 0 to display. So we're going to do if I equals 0, so remember our operators, then we are going to use our keyword continue. This will skip the loop and reset it, and it will go back up here, and then we'll go on to the next part. Else, then we want it to print out, so if it does not equal to 0, we want it to print out the value of I, std, end line. Alright, so let's test this out. We hit compile, we run it, we get 2, 4, 6, 8, 10. Hey, that works pretty good, right? Well, and it's a good way to show how our continue works. There are better ways to do this. So again, I'm just going to comment this out real quick. Collapse that down. Let's go to version 2. In version 2, we're going to make the condition a little bit better. So we're going to do for int I 0, semicolon, I is less than or equal to 10. And we're going to still increment it by 2, just like we did before. Except for what we're going to do now is we're going to do if I is not equal to 0, then all we're going to do is std cout I std end line. So this should run exactly the same. 2, 4, 6, 8, 10. But I've also mentioned, this is a bit of a trick. Notice that it says from 0 to 10 in steps of 2 without displaying 0. Well, we know we're not going to display 0 or 1. So what we could do instead, after I comment this out, is make a just smarter design to our loop. So just to be mindful of these sort of things. And all we have to do is for int 2, put the semicolon in the right spot, I is less than or equal to 10, should be no space there. Then we're going to increment our I by 2. And all we're going to do is std cout I, std, end line. And this should run exactly the same. And this should run exactly the same, except for I forgot to include the I there. So let's now try that. So we have 2, 4, 6, 8, 10. So don't write code you don't need if you can work around by doing things like this instead of having to make all these checks. Make things simple. All right. So on to challenge 3, we want to create a loop that displays all values that are evenly divisible, so no remainders, by 20, between 0 and 10. And you might think, oh, we can skip, all the way up to 20. Well, 0 is actually evenly dividable by 20. It's 0. So we do technically need that in this one. If I didn't have between 0 and 10, I said up to 100, we probably could just get away with it, but I said I wanted 0. So we're going to have that in there. So what we're going to do is for... So we're doing a lot of for loops, if you haven't recognized that. Int I at 0, I is less than or equal to 100. We're going to increment I by 10. And the reason why we're going to increment I by 10, this is where we're being smart, is we know we don't need to run this 100 times. We know that 21 is not evenly divisible by 20. We know 34 isn't evenly divisible by 20. Only the tens numbers will be, so 10, 20, 30, 40, 50, 60, 70, 80, etc. So we only care about those numbers. So what we'll do is we'll put our bracket in there. We'll do if I modulus operator. So if you don't remember that, go back to our math operators. 20 is equal to 0. So in other words, if there's no remainder, then it's evenly divisible by 20. We will then std cout our value std end line. So let's just hit our compiler there, and we have 20 or 0, 20, 40, 60, 80, 100. All right, so that's fairly simple. Let's again just comment this out. And you might be wondering why I'm making sure I don't get that little spot right there. Having these sort of comments, and that's the easiest way to do that with that hotkey I've been using. All right, so challenge 4. We want to create a loop that displays all values from 1 to 100 in rows of 10. Now, there is 2 ways of doing this. We'll start with the simple way, which just shows, it uses the same math operators we're familiar with. And then we're going to do a version we've talked about, but we haven't actually used in practice yet. So first, we'll talk about a for int I at a value of 1, because we want 1 to 100. And then we'll do I is less than or equal to 100, and we're going to increment I by 1 each time this loop runs. And in this loop, we're going to std cout the value of I. We then need to check, is this value 10 or not? If it is 10, then we are going to put an end line. If it is not, we are going to put a space. So we're going to do if I modulus operator 10 is equal to 0. So this line here is saying if our value is 10, then we'll go on. So we'll do an std cout, standard library cout, and then we're going to just do std again, end line. So this will put in a space. Else, so in other words, if it's not equal to 10, or if it isn't the 10th integer in our list. So remember, if we divide something by 10, 10 is divisible by 10, it will be 0, no remainder. 11 will have a remainder, 12 will have a remainder, 20 won't, 25 will have a remainder, 30 won't, etc. We are just going to put in std cout, and then we're going to just put 2 quotes with a space between them and a semicolon. So this will run what we want. So we have 1 to 10, 11 to 20, 21 to 30, all the way down to 91 and 100. But there's a more efficient way to write this. So let me just comment this out, and we'll explore that more efficient way. And that's our version 2. Now, before I do version 2, the operators I'm going to use, if you don't remember them, I strongly recommend re-watching video 11 of this series. We can reduce all of this code right here down to 1 line. So what we're going to do is we're going to do a for loop int I value of 1. So the for part remains the same up to and equal to 100. And then we increment our I. What we're going to do here different is std cout. We're going to output our I, and then we are going to do our modular operator. And yes, I meant to put 2 brackets in. So I modular 10 equal to 0. And then we're going to follow that between the 2 brackets by a question mark. So this is an if statement where if it evaluates to true, it will do the first thing we're about to write. If it is not true, it will do the second thing we write. So if this is true, then we want to go down a line. And remember, this is the same as saying std end line. And then we have our colon to separate the two options out. So if true, if I is equal, or I modular operator 10 is equal to 0, so if it's a 10th integer, then do this. If it is not, then do this. Put a space in. So if we run this, we'll get the same result. 1 to 10, 11 to 20, all the way down to 91 to 100. So again, if you're not familiar with how this works, we covered this in video 11. We just haven't used it yet. I recommend reviewing video 11 if you're confused by this. So let's comment this one out and move on to challenge 5, where we're going to determine if a value that's entered by the user is a prime value or not. So if you don't remember what a prime number is, well, let's just go over that real quick. A prime number is a natural, so a whole number, greater than 1, keyword, that cannot be formed by multiplying two smaller natural numbers. A number greater than 1 is not prime, it's called a composite number. Okay, so that's all we need to know. And for those of you not familiar, in the world of math, 1 is not a prime number. So we don't need to worry about 1. It will automatically take care of itself in this. So first we need to do is declare some variables. We need to declare int, so integers, a number that the user is going to enter, and then we're going to have a testing number. And you can declare variables of the same type on one line. We're going to initialize these both to 0. So instead of having int on one line, number equals 0, int on another line, test number equals 0, we can do this all on one line, and it will work perfectly fine. We're going to do an std cout, and we're going to ask someone to enter a number. So please enter an integer. And then we're going to do our end line. I don't need that extra space at the end, but I always do that out of habit. So then we have an stdcin, and we need to read in the number. So this test number, if you think about what a prime number is again, a prime number cannot be made by multiplying numbers that are smaller than itself to equal that number. So we need to be able to run something through and test, can we multiply this and this to get the number we're looking for? So that's what that test number is for. It's what we're using to test if our number is a prime number or not. So we're going to do a for loop. So for int I, we're going to start with 1, and we are going to run until we get to the number we care about. And I'll explain why it's going to be less than or equal to in a second. So we want to run up into the value that the user has inputted, and then we're going to increment our I. So this is where it gets a bit complicated. In here, we're going to set our test number. So what we're going to do is we are going to do if number modular operator I, so the number divided by I, and we're going to get the remainder. If the remainder is 0, in other words, that number is evenly divisible, just like we did up in challenge 3, by the value that we're currently going through in the iteration, then what we want to do is we want to increment our test number. So why are we doing this? Well, this is where we can tell if our number is prime or not. A prime number will only have a test number of 2. Anything else is going to have a test number greater than 2. And the reason for that is a prime number is only divisible by 1 and itself. So for example, 3 is only divisible by 1 and 3. This would make it 2, which is why we have this equal to the number. We need to check itself. If it has a value greater than that, so let's take 4 for example. 4 is divisible by 1, so we increment test number to 1 from 0. 4 is divisible by 2, so we then will increment this from 1 to 2. 4 is also divisible by itself, so we'll increment it from 2 to 3. So then all we're going to do outside of our loop is have an if statement. If test number is equal to 2, so if it's prime, then we are going to do an std cout number with an extra space this time intentionally put in is a prime number. And then we're going to do our standard library end line else. And the reason we're doing else is 1 isn't a prime number. It actually is only going to have a test number value of 1 here. So cout number space intentionally again is not a prime number. So full stop, std, end line. All right, let's test this out, make sure it works. We're gonna do this a couple of times. Let's start with one we know is a prime, not a prime number, 4. 4 is not a prime number. Let's do this again with one we do know is a prime number. Let's go with 5. 5 is a prime number. Let's do 99. 99 is not a prime number, by the way. There we go. So let's do another large number. Let's see if we can get a large non-prime, or a large prime number. Let's do 193. 193 is a prime number. It's only divisible by 1, so we'll increment it there, and by itself. So it'll have an increment again. It will have a test number value of 2, and therefore it is a prime number. All right, let's comment this out and go on to our next challenge. So for our next challenge, we want to create a loop that will iterate a number inputted by the user and give us a factorial of every number up to the number inputted. Now, if you put a really large number in here, you're going to realize it'll stop correctly calculating it, and that's just because of the limits on the sizes that can be held. So we're going to have an int, and it's going to be number, and we're not going to initialize it to anything, and then we're going to have another integer, and we can't do this on the same line because they're going to have different values, called factorial. And we're going to initialize this to 1. And we're going to do std_cout. Please enter a non-zero positive integer. I'm not going to put the space in I don't need. std. Apparently I put the quote in the wrong spot, so let me just quickly fix this. Sorry about that. Standard library, end line, and then we're going to do a standard library cin, and we're going to see the number inputted. And then what we're going to do is an if statement first. So the loop isn't going to be the outer statement. If the number is greater than 0, then what we're going to do, we do need our brackets this time because we're going to have a compound statement, is run a for loop. So we have a if on the outside and a loop on the inside. Int I, initialized to 1. I is less than or equal to the number. So we want to run this for the length of the number put in, or as many times as the number that has been put in. We're going to increment I. And what we're going to do in here, we need another compound statement, is factorial is equal to itself, or is equal to I times itself. And then we're going to do an std_cout I, no space this time, exclamation mark, because that is our factorial symbol, is equal to, and then we're going to have a space, and we're going to print our factorial. std end line. All right, so that's our if. Now we have our else to do. Else, in other words, if it is equal to, if it is not greater than 0, so if it's 0 or less than, all we're going to do is std_cout. I said a non-zero positive integer. And then we're going to do an end line. All right, so let's make sure this works. All right, I'm going to enter the number 6, so it should loop through this 6 times. You should get 1 factorial equals 1, 2 factorial equals something. So there it is. 1 factorial 1 is 1, 2 factorial 2 is 2, 3 factorial 3 is 6, 4 factorial is 24, 5 factorial is 120, and 6 factorial is 720. All right, so that is how this one's going to work. Let me again comment this one out, and let's move on to the next challenge. So this one requires you to go back to remember how our random numbers work. We're going to create an array that stores how long someone's exercised and print that value. I realize the wording here is a bit off. I apologize for that. Now, as I said, this uses random numbers, so it requires you to go back to something we've done previously. So let's take care of what we need to make this work. We need a couple of headers here. We need our C standard library. So let's do hashtag or # C standard library. Then hashtag or # include C time. So this is how we're going to get our random numbers. All right, so first thing I'm going to do here is I am going to initialize my seed for this one. So I'm going to do srand time null. Also, I put too many brackets in that time. That time was not intentional. All right, and I need to put the semicolon at the end there. So srand time. And then I'm going to get a constant, just to show you how this works, integer called days in year. Now you know where this came from in the last video. 365, semicolon. Then I'm going to do a float time exercised. I spelled that wrong. Exercised per day. And then it's going to be days in year, semicolon. So now I also mentioned I'm going to intentionally show you an error when you don't use the right values. So I'm going to show you what happens when we go out of bounds. And this is where the error lies. I'm going to do int I equals 1. And this will not work correctly, and you'll see why in a moment. Now I'm going to do my for loop using a range-based for loop. For float, or I could use auto here, by the way, remember. I could do auto, x, colon, instead of semicolon, time exercised per day. All right, now I'm going to get a random float each time I do this, and I'm going to set the random float to be divided by 90, because I'm thinking hours and minutes, or maybe just minutes. Who knows what I'm thinking? Just using a random number. Random num equals rand function modular 90. All right, and then I'm going to do another random number so I can actually make sure it's a float. So I'm going to do random modifier, which is going to be another rand modular 10. Now I could leave it here, but if I do that, I'm going to run into an error where I'm going to get something called infinite, and that's just because it might be 0. We can't divide by 0, so I'm going to do +1. All right, so I said divide. What I'm going to do is I'm going to divide random number by the modifier. That way I can get that floating point value. So then we're going to go time exercised per day at index I, because remember we declared I up here, is equal to random number, or random num, divided by random modifier, or rand modifier is what I called it here. Okay, sorry about that. So the value at this point will be equal to this. We are then going to std cout on day I +1. And again, this isn't an intentional error. This is related to why this is wrong, though. Time exercised was. And then I'm going to do, I can either do times exercised. Actually, I'm going to do it this way just so I can guarantee we'll see the error. There are better ways to write this particular line, but I want to show you an out of bounds error. All right, so we're going to output the time on day 1, 2, whatever, the time exercised was whatever this random number is. And then we are going to increment I. All right, so if we run this, we're going to get an error. It will run, but we will get an error. There's that error I was talking about. We are out of bounds in this case. And we can take a look at the code and see why fairly quickly. So let me get the window back open. 366. On day 366. On day 2. So you might think, well, I've done something wrong here. If I get rid of this, it's still not going to work right, because the first value in our array is always 0. So if I change that to 0, let me just hit stop and then rerun this, it will work perfectly fine. There we go. I mean, we got some really random numbers in here, so yeah, take that for what you will, but hey, it works. And again, there are better ways to write this line. I just really wanted to show you how out of bound looks. And we're going to comment this out. And let's go on to the final challenge. Now, the key to this challenge is, again, the wording. We are printing the values in reverse order. We are not storing the values in reverse order. If we wanted to store the values in reverse order, we have a lot more work to do. Now again, with C++20, there are things we could do to make it really simple and really easy, but unfortunately those are not supported by the current IDE, or Visual Studio 2019. So worry about that later. And we're gonna do versions 1 and 2 basically in one go. So first, we're gonna declare a character-based array called letters. And we are going to set this to a size determined by the compiler, and the first value will be A, followed by a value of B, followed by a value, that should be single quote, followed by a value of C. Spaces actually don't matter. And then remember, with these, we need a null terminator. So there is our null terminator. I'm not sure why it moved it over. Okay, let's just pop that back into the correct indentation. And then we're going to do int I equals 3. And this is where we're going to change things around. And we're going to do while. So this is our first while loop today. Just want to give you a refresher of it. I is greater than or equal to 0. We're going to do something. And we're going to print. We're going to do an std cout letters at index I std end line. And then we're going to decrement I. So the first time this runs, it will print the value at 3, which which will be our C there, and then print the value there and there. Actually, this is technically, it's going to try to print the null, but it won't print it, so it's going to go through. This is technically not the best way to do it, which is why we're going to fix this in a minute. This also is slightly error prone, but fortunately, because we already have that null terminator, we're not going to get the error. We just had that space there. That space is due to, well, the fact it's printing the null statement. If we change that to 2, this will actually not have the space. CBA, there we go. But there's still a better way to do this. This only works if we know the size of the array we're working with. Well, if we don't know the size, or we don't know if the values in there are still, valid, or if it's a vector and thus the size changes, the computer can know the size, and we as programmers don't need to know it. So what we can do is we can use a function, and if you looked at the links in the earlier videos, you'll recognize this function called size of letters. And then we're going to do -1. This we can use to have the compiler determine what I is. If we run it, there we go. We have CBA. Actually, if we do -2, it's actually still doing the null terminator. It will run better. It'll drop that null terminator out. But I always say do the -1 approach. It's just simply better. All right. That takes us through our challenge. If there are parts in this that you struggled with, go back and check the other videos out that led up to this point, or rewatch this video. Make sure to look at the links that I put in the descriptions. All of that said, that covers everything we need to do in this video. We'll go on to talk about strings in C++, and then we'll get our word list and pick our random word from that list in our Hangman game. So if you like this video, make sure to hit that like button down below. It really does help this channel out. Also, if you want to be here when those other videos come out, make sure to hit the subscribe and notify icon so you know when those videos are released. Also, consider becoming a supporter on Patreon. It really does help this channel out. And finally, I look forward to seeing you in the next tutorial, and I hope that you have a wonderful day.